So I'm going to share my screen. Hey guys, here's our next section, 9.7. We're going to solve systems of quadratic equations. So you don't need to worry about the steps. Everything is going to be pretty much explained when I do the first problem. So when you're solving, you're trying to figure out where this graph, which is a linear equation, crosses, if it crosses this quadratic. So if you were to graph it, you would physically see where this line crosses through this parabola. So we're not going to graph it, we're only going to solve it. And what we're going to do is since they're both already set equal to y, we're going to set the two equations equal to each other. So the first one, 3x plus 2, is equal to the other equation, our quadratic. So at this point, we want to set everything equal to 0 and combine our like terms. So I'm going to bring this 3x over and combine it with the 6x. So I'm going to subtract 3x, subtract 3x. So we have 2 equals 3x squared. This is a positive 3x. Opposite signs you subtract, larger number controls, and a plus 2. Now we're going to bring the constant over, so minus 2, like terms. There we go, it's a little bit clear. So now we have 3x squared plus 3x. Well, the 2's end up canceling also. So we're left with this, and this is equal to 0. Doesn't matter which side you put it. Well, we want to know what the x values, 3x squared, sorry. We want to know what the x values are. So since it's a binomial, we're only going to be able to factor out what they have in common to solve for our x's. So they both have a 3 in common, and they both have an x in common. So take that out. What's left inside is an x. Remember, you always want to distribute, multiply it back in to make sure you come back to your original. So 3x times x does give us 3x squared. And then we took a 3x out. So that means we would need a 1 there, because if we distribute back in, you should go back to our original. Set that equal to 0. Now at this point, since it's factored completely, now we can separate to solve for our two x values. So if I cover up our expression, set this equal to 0. So 3x equals 0, divide by 3, divide by 3. Our first x value is 0. Then I'm going to take the expression and set that equal to 0. So we have x plus 1 equals 0, minus 1, minus 1, and then our other x value is equal to negative 1. So that means it crosses, they touch at those 2 points. So that means if we were to graph it, the line itself crosses through the parabola at where x equals 0 and where x is equal to negative 1. So that's example 1. Then I recommend that you pause the video or go back, log in to the textbook, and copy this key concept into your notes. So this gives you a visual of what happens when there's no solution, there's one solution, or there's two solutions. So the problem we just did, it gave us two solutions where x is equal to 0 and x is equal to negative 1. So it's going to have a scenario like this, where the line crosses through the parabola at 2 different points. If you get a no solution, that means that your line does not intersect the parabola. If you only get one solution, that means it hits exactly at 1 point. It's tangent to it. So now I'm going to do example 2. They talk about doing it with a graphing calculator, but I'm not going to use my graphing calculator. We're going to solve it. So here's example 2. It's our line and our parabola. since they're both already set up for y's, we're going to set the two equations equal to each other. So we have 2x minus 4 equals x squared minus 4x plus 1. So it's going to combine our like terms. Going to bring the 2x over there, so minus 2x minus 2x. We have minus 4 is equal to x squared minus 6x, same sign you add and keep the sign, plus 1. Now I'm going to bring my constant over, so plus 4 plus 4. So now we have x squared minus 6x plus 5, and this is equal to 0. So now we have a trinomial. Before we had a binomial, we only had two terms, and we factored out what they have in common to solve for our x's. But for this one, we're going to try and factor it. And let's see what happens. So for our leading term, it's x and x. Since 5 is prime, we don't have any other choice of products except for 5 and 1. We want to reach that middle term of a negative 6x. Well, our outer gives us 5x, our inner gives us 1x. If we add them, we'll get the 6, but it has to be negative, so they both have to be negative. Same sign you add and keep the sign, so they're both negative. Perfect. And then a negative 1, excuse me, and a negative 5 gives us a positive 5, so we're good. We factored correctly. Well, now we can solve for our two x values. Cover this one up, set this expression equal to 0. So we get x minus 1 equals 0, plus 1, plus 1. We get our first, there we go, it's better. So we get our first x value to be positive 1. So it crosses through at positive 1. Now I'm going to cover up that expression and set this one equal to 0. X minus 5 equals 0, plus 5, plus 5. So we get x equals 5. So those are our two x values. So that is 9.7, solve systems with quadratic equations. Make sure you start the homework and you watch the next video for 9.8, which will be up soon. Bye, guys.